Year after year, as man's collective knowledge grows, his capacity to reach further into the universe and his ability to understand and control the forces of nature, and his know-how in devising the tools to make his life comfortable, have increased. The answers to some of the most challenging questions are coming from space. There are meteorites that have landed on Earth from outer space, some with a history dating back 4.5 billion years, and they are being found in relatively large numbers in Antarctica. Literally tens of thousands have been collected from the icy wasteland over the years. And considering only around 2,000 specimens existed in total before the Antarctic discoveries, the cache has been a scientific boon. Meteorites are small fragments from an asteroid belt that might have helped form planet Earth. So here in these frozen conditions is some of the oldest material in the solar system. By studying meteorites, scientists hope to find the answers to two fundamental questions. Is there life beyond Earth? And what are the processes that led to life on Earth? The cornerstone of the investigations was the search for organic compounds known as amino acids within the meteorites. Amino acids are the building blocks of life on Earth, and as it was discovered, also exist in the Antarctic meteorites. Importantly, these organic compounds were different from any found in living organisms on Earth. Could it have been that meteorites were the seeds that sowed life throughout the universe? Many scientists now ascribe to this theory. Man's investigation of space, indeed his investigation of life itself, has been an outward-looking one. But with the gathering of meteorites from across the face of the planet, scientists have been able to unlock the door to a myriad of secrets our universe has kept hidden for millions of years. Could it be that one day we'll discover exactly how life came to be? The scientists say the answer must be yes, but until then, they can only look to the stars and wait. In 1959, despite the heroics and grand plans, the realities of space were still largely unknown to the people of the fledgling space program. From exhausting testing, often testing for things they were not even sure existed, 7 men were chosen for America's first foray into manned space exploration, the Mercury Project. To explore his world, man has always risked the unknown because it is unknown, and it is man's nature to know. The problem of selecting pilots was approached from an uncompromising, hard scientific viewpoint. From all the active pilots in all the branches of the armed forces, the service records of 473 test pilots were selected for review. 110 met the basic qualifications. The successful candidates were put through a barrage of tests, not just the normal diagnostic tests, because as military pilots, these men were regularly checked, but also a range of dynamic tests were designed to see how they operate under stress, both physical and mental. A complete profile of each pilot's physiology was mapped so that it could be compared by telemetry from capsule to Earth, should they be on board one of the Mercury capsules. This microscopic approach gave the ground crew baseline information to compare against later flight data. This Project Mercury candidate is preparing for stress. The weight of 8 gravities will be thrust upon him as he rides the centrifuge. His reactions are studied and analysed to see how he fared under multiple gravity forces. After many tests, 7 remained, and they began the real training. They wanted to know all the answers and prepare as well as they could for any eventuality. All of this to make astronauts what they really are. The odyssey of a mission aboard the shuttle begins about a year before launch, when individual astronauts are assigned to a crew for a specific flight. From then on, it's non-stop preparation all the way to the launch pad. Finally, the moment they've waited a lifetime for arrives. At T-minus 6 seconds, the orbiter's 3 main engines ignite, unleashing enough thrust to power 7.5 747 jumbo jets. Powerful turbo pumps begin flowing fuel to the engines at a rate that would empty an Olympic swimming pool in 25 seconds. The main engines are soon joined by the solid rocket boosters, adding a further 44 million horsepower. And by the time the shuttle clears the tower, it's already travelling at more than 100 miles per hour. As it accelerates up the hill, it's generating more power than 23 Hoover dams. And in a matter of minutes, the shuttle and its crew of astronauts will be in space. Once in orbit, the long months of preparation are put to use in workdays that average as many as 16 hours. Hours filled with scientific experiments, medical research, environmental and atmospheric studies, and the list goes on. Some crews will deploy multi-million-dollar satellites, while others may leave the spacecraft to rescue one. There are also more mundane chores to perform, such as housekeeping and meal preparation. But the time in space is not all work. There's also time for the unique recreational opportunities found only in space. Or just to take in the spectacular beauty of the moment. There's no denying that a ride on the shuttle is the best seat in the house. But what goes up must come down, and the same is true of the shuttle. After a journey of more than 1 million miles, each astronaut returns to Earth with unforgettable memories and already looking forward to his or her next trip into space, as the dream of reaching for the stars lives on. When NASA's Hubble Space Telescope was launched in 1990, the scientific community and the public eagerly awaited the discoveries that would be made by the orbiting telescope. the galaxy closest to our own Milky Way is a favorite target for the Hubble. Known as the Large Magellanic Cloud, it's home to supernova 1987A, which provided one of the telescope's earliest and most intriguing discoveries. This supernova was the result of a huge explosion, which catapulted a tremendous amount of neutrinos into interstellar space. Planetary nebulae are formed as a star, like our own Sun, but run out of nuclear fuel, collapse and die. Thousands of these are known in our own and other galaxies, but they've never been imaged before. The most massive star known is also found in the Large Magellanic Cloud. Melnick 42 is a giant star that is equal in mass to 100 stars like our Sun. The most powerful ground-based observatories are unable to distinguish the thousands of densely packed stars in globular clusters. The Hubble Space Telescope allows astronomers to study these tightly knit collections of old stars with unprecedented clarity. Hubble's capability has led to the discovery of a unique class of star called blue stragglers in the core of a globular cluster. The telescope also provided astronomers with the rare opportunity to observe a white spot on Saturn. The spot was later deemed to be a storm, somewhat like a thunderstorm on Earth. Several space telescope images were taken during Saturn's 10-hour rotation period. The images were combined to provide a movie of the turbulent activity in Saturn's atmosphere. This new data is extremely valuable for people trying to understand how atmospheres work, which in turn has a long-term practical application for us, because that's how we improve our weather forecasting. It's hoped that telescopes may confirm much of the speculation concerning black holes. A black hole is an object, typically a collapsed star, whose gravity is so strong that its velocity exceeds the speed of light. Previously, black holes observed by Hubble have been largely hidden from view because they are embedded inside a torus, a donut-shaped distribution of dust that forms a partial cocoon around the black hole. NASA's Hubble Space Telescope has now provided a never-before-seen view of a warped disk or ring of dust caught in a blazing torrent of ultraviolet light from a suspected massive black hole. In galaxies previously studied, the intense light from superhot gas entrapped by the black hole's powerful gravitational field shines out from inside the donut hole of the torus and is restricted to a narrow beam, like a searchlight. Observations by Hubble are continuing to advance our knowledge of the universe. Here in Waynesville, North Carolina, something very special is going on. This is Dee Roper and his son Stevie. Stevie was born with a very rare physical condition, lacking sweat glands. His body had no natural way to cool itself. Until recently, too much physical activity, or even limited activity on hot days, would have been tragic. But Stevie now has a great way to beat the heat, a liquid-cooled outfit based on NASA technology. This small pump and heat exchanger cools and recycles fluid through a vest and hat, a system used similarly in astronaut spacesuits. Stevie can wear the outfit while exercising if it's convenient, or simply put it on intermittently to cool down. It's made a tremendous difference to Stevie's life. The suit has meant a newfound freedom and peace of mind, not only for Stevie, but for his whole family. His performance at school has also improved. Before the cool suit, he was constantly getting drinks or applying cool towels, which made it difficult for him to concentrate and get his assignments done. Now when he gets too hot, he simply dons the suit and continues working. Probably the most significant factor is that Stevie is in school more often, because the suit has reduced his susceptibility to respiratory ailments like bronchitis or pneumonia. Efforts are now being made to make this suit available on a global scale. January 31st, 1971. Alan B. Shepard makes his second spaceflight, this time as commander of Apollo 14, the country's third moon landing. With astronauts Mitchell and Russo accompanying Shepard, Apollo 14 marked the beginning of large-scale use of the moon for science. These are some of the 94 pounds of lunar rocks that were returned from the moon's ancient hills by Apollo 14. They were just beginning to tell scientists their story. A story 3.5 billion years old. From them we learnt about the early history not only of the moon, but of other planets as well, the Earth, Mars, even Venus and Mercury. This was the view seen by Apollo 15 astronauts Scott and Irwin as their spacecraft Falcon descended towards the foothills of the moon's Apennine Mountains.
Okay, Houston, the Falcon is on the plane at Hadley. Roger, roger, Falcon.
Theirs was the most expensive exploration of the moon ever made. To prepare for the mission, Scott and Irwin practiced on similar Earth terrain at the Rio Grande Gorge in New Mexico. They also spent many hours getting used to the lunar rover. Here's what it actually looked like to the moon riders as they drove their four-wheel buggy over 16 miles of lunar surface. As a result of their increased mobility, the pair returned 180 pounds of lunar rocks and deep core samples. After liftoff, and while still in lunar orbit, the trio launched a small scientific satellite called the sub-satellite to study the area around the moon. As they headed earthward, astronaut Al Walden climbed outside the spacecraft and retrieved film from a pair of mapping cameras. The scientific instruments left by Apollo 15 and the samples they returned gave us a real understanding of the moon and its relationship to both the Earth and the Sun. It may not look like it, but these black boxes represent a revolution for satellite communications. This is a Merhis, a payload which will be the first switchboard in space. It's being cautiously prepared by European engineers. Basically, this is an onboard processor that will allow satellite capacities to be used much more efficiently. A Merhis is a piggyback payload on Hipposat's satellite Amazonas. From the geostationary position, it will provide high-performance interactive multimedia services through the 4 coverage zones of Amazonas: North America, South America, Brazil, and Europe. A Merhis introduces a space-based switched multimedia system able to provide broadband services and connectivity to user terminals across 2 continents, thus optimizing satellite resources. With a Merhis, there is no need for a double hop as in classic transmissions. One single hop is enough to connect terminals in separate beams. The satellite is not just a transmission system, it becomes the core node of a broadband digital network. Direct connection is now possible between users in different coverage areas of the transponders of Amazonas. Thus, AMERHIS permits everything from intranet access to audio and video communications or telephony services. It is a world first in the use of satellites, which could be important when we are looking for solutions to bridge the so-called digital divide. This may become the mission control room of the not-so-distant future, for a spaceship so highly advanced, fast and versatile that it would render the space shuttles as obsolete as the Apollo rockets. Able to fly direct from airport runways into Earth orbit and withstand temperatures of up to 5,000 degrees, the National Aerospace Plane represents the future in aeronautics and space technology. NASA and the Department of Defense are co-sponsoring a unique cooperative effort among aerospace companies to design and develop the airframe, materials and systems for the National Aerospace Plane, scheduled to begin flights in the not-too-distant future. The aerospace plane follows in the footsteps of a distinguished series of experimental aircraft that overcame many obstacles. Beginning with the Bell X-1, Chuck Yeager's historic flight broke the sound barrier. In the 60s, the X-15 flew at 7 times the speed of sound. And the X-29, with its sophisticated forward-swept wing design, proved that advanced materials and computer-aided controls yielded unmatched maneuverability. When the next experimental plane, the X-30, becomes a reality, it will harness a set of ramjets, scramjets, and finally rocket propulsion, flying directly into orbit. The promise of low-cost access to space has also encouraged the Europeans and the Japanese to begin working on their own versions of the spaceplane. While the interest in creating such a technology is very high, it presents unique and even daunting challenges. No existing plane or wind tunnel can duplicate the 17,500 miles per hour the X-30 will attain. Computer models are being used to simulate the shock waves and heat the X-30 will encounter as it roars through Earth's atmosphere nearly 30 times faster than a jet airliner. Materials for the plane must meet rival needs of strength, lightness, and the ability to withstand searing temperatures at re-entry. Unlike a previous design resembling a Concorde, the X-30's wide fuselage provides much of the plane's lift and reduces wingspan requirements. A wide nose directs airflow into the plane's air-breathing ramjet and scramjet engines. Dual vertical tails have been added for greater stability at all speeds. It is hoped that this technology will offer affordable, efficient, and flexible access to space.